in this video I will be working out a voltage drop across a resistor and the power consumed in another resistor. So we've got a series circuit. We've got two resistors. R1 is 5 ohms, R2 is 7 ohms. So they're in a straight line, so it's a series circuit. And we have a voltage source, like a battery if you like, of 10 volts. It's called E for EMF, electromotive force, but it could have been called V. It makes no difference. If it's got volts on the end, then it's a voltage source. We could call it Bob or Ethel if we like, it doesn't matter. So to find a voltage drop across one of the resistors, we need to find the current in the resistor first. So let's start off with Ohm's law, which is what we'll use for these types of questions. So we've got V is equal to I times R, if you want to use that little triangle. So if we write it as a straight line equation, V equals IR, where voltage is the current in amps times the resistance in ohms, and V is in volts. But I prefer this little triangle because V equals I times R. If you want to know what I is, you cover it up. I is V over R. If you wanted to work out what a resistance was and you knew voltage and current, then cover up resistance. R would be V over I, V divided by I. And if you want to know what V is, cover it up. V equals I times R. So that's why I find this useful. It's dead easy to rearrange or transpose this formula. So anyway then, find the voltage drop in R2. Like I said, first of all, to find a voltage drop, we need to know a current. Because V equals I times R, we need to know the current if we're given the resistance. So in order to find the current, I, we have to know the total resistance of the circuit. So I suppose step one is find the total resistance, which I'll call RT. Find the total resistance, and because they're in series, it's really easy. The total resistance of this circuit is 5 ohms plus 7 ohms. So it's 5 plus 7, which is 12 ohms. So that's the overall resistance. So what the circuit really looks like is like 10 volts, and then there's a resistor there, which I could call RT, and it's 12 ohms. This little circuit I scribbled is the same as this one here. They behave in exactly the same way. So we found the total resistance is 12 ohms. So now we know the total resistance and we know the voltage, we can find the total current. So the total current, I'll call it IT for I total or current total, is equal to the voltage, the total voltage, which is 10 volts, divided by the total resistance. So the total current is equal to 10 volts divided by 12 ohms, which is the combination of the two series resistors. 10 divided by 12 is equal to 5/6 or 0.83 recurring amps. So the 3 goes on forever. You can put amps or you can put capital A for amps. So we've got the total current is 0.83 amps. Now we've found the total current. There's only one current in this circuit because there's only one loop. So it just goes out here clockwise, back in again. We know it goes clockwise because we've got the anode of the battery, the positive bit there, and the little bit is like the negative. So conventional current, we say, flows from positive to negative. So now we can actually find out some values. First of all, we have to find the total resistance and the total current through that total resistance. Now we can single them out individually. So for question 1, we can actually do it now. The voltage drop across R2, because a voltage drop is between 2 points, I'm going to call it VR2, which is the voltage across R2, which is the voltage across here, is equal to the current, because there's only one current flowing, times R2 itself, because Ohm's law, remember V equals IR. So voltage drop across a resistor is equal to the current through it times its resistance. So voltage drop across R2 is the current times R2 itself, which is 0.83 recurring amps times R2's value, which is 7 ohms. So all I need to do really, because I've still got my calculator with the last value in it, so the calculator's already storing 0.83 recurring amps. So I'll do the answer times 7 ohms, and that is 5.83 recurring volts. So the voltage across R2 is 5.83 recurring volts. You can put that in brackets if you like as your units. It's all very well using answers stored in your calculator. It's great if you're sure that they're there, but sometimes it's best to type them out again just in case. Depends how confident you are that the answer is still in the memory. So just to double check, I'm going to do 0.83 recurring, so do as many 3s as I can, times 7 ohms. And it gives us 5.83 volts. So we know we've done that right. So for part 2, find the power consumed. It's going to be consumed as heat because it's a resistor. It's not a motor or anything. It doesn't do anything apart from get hot. So it's the power consumed in this resistor here. So power, there's different ways of writing the formula, but a good one to use is I squared R, which is the current squared times the resistor that you're on about. So power in R1 I'll call PR1. You can call it what you like. It's equal to the current squared. Remember there's only one current because it's a series circuit. 0.83 recurring squared times the resistor value of R1, which is 5 ohms. So do 0.8 all 3s squared times 5, which gives me 3.472 recurring, and because it's power it's going to be in watts. 3.472 recurring watts. W for watts. The question will tell you how accurately to put the answers, but I would suggest that 2 decimal places or 4 significant figures, depending on what figures you have, is reasonable. So the power that they're asking for is 3.47 watts, which is to 2 decimal places.